This is the Precalculus class notes for section 1.3. Here we're doing a review on more on functions and their graphs. And again, here are their learning objectives. Please read through those. Please read through the e-text to get more specific. And here's some examples I've constructed for you to understand how to do the homework. So the first of these is we want to find and simplify this thing called the difference quotient. This looks a little unusual probably, but this is actually something that you have to calculate in calculus quite a bit. So this is why you learn about how to calculate this in pre-calculus. Of course, h cannot be 0. You can never divide by 0. So it's f of x plus h minus f of x all divided by h. And let's look at this function f of x equals minus 2x squared minus x plus 3. Let's go look at that on the next page of your notes. So here's the function. So I'm going to break this up into a couple different pieces. Recall, this is what we want to do. F of x plus h minus f of x over h. So let's look at f of x plus h first. So we know that when we evaluate a function like this, we want to stick the quantity x plus h into the function f of x everywhere I see an x. So that means I have minus 2 times the quantity x plus h squared minus quantity x plus h plus 3. So the only thing maybe slightly complicated is to FOIL this quantity x plus h squared, x plus h times x plus h. When you do that, you get x squared plus 2xh plus h squared. So then I just now have to do some basic simple algebra and simplify this guy, okay? So this is what I get for f of x plus h, minus 2x squared minus 4xh minus 2h squared. When I distribute the minus 2 through here, distribute the minus 1 through here, I get minus x minus h plus 3. Okay, then if I take that quantity f of x plus h and I subtract f of x, basically everything what will happen is all the terms in f of x will cancel with terms that you got from f of x plus h. So the minus 2x squared cancels with minus a minus 2x squared. The minus x cancels with minus a minus x. And the 3 cancels with minus 3. So those all cancel. So what do I have left? I have the minus 4xh and the minus 2h squared from f of x plus h, and I have the minus h as well. So just the terms that are left in f of x plus h is all I have left. The nice thing about this is notice every single one of these terms has an h in it, so I can factor out an h. By the way, every single term here has a minus 1 in it. I'll factor out a minus 1 too. So I'm going to factor out a minus h. That leaves me with minus h times the quantity 4x plus 2h plus 1. Okay, then finally when I take that f of x plus h minus f of x and I divide it by h, these h's cancel and I'm left with minus, when I distribute it through, minus 4x minus 2h minus 1. So that's example 1. Example 2 says find h of minus 5 if h of x is defined this way. So h of x is defined as x plus 4 if x is greater than or equal to minus 4, and minus the quantity x plus 4 if x is less than minus 4. So this is what's called a piecewise defined function. For piecewise defined functions, we have to look over here. It tells us what values of x we want to have to use which piece of the function. So we want to evaluate h of minus 5. That means when x is minus 5, I look over here. This is the situation when x is less than minus 4, which includes x equals minus 5. So when I plug in minus 5 for x in this piece of it, that's the evaluation of h of minus 5. So that'd be minus the quantity, minus 5 plus 4, or minus a minus 1, which is 1. All right, in this third example, I want to determine whether a function is odd, even, or neither. And a function is even or odd is defined in a certain way, okay? So if I go over here to the next page, I labeled this as 2. That should have been labeled as 3. I apologize. If you were to plug in minus x into the function, and you either get minus f of x, what f of x was originally, minus f of x, in other words, opposite of what it was originally, that's what's called an odd function. We'll see later that that means the graph of that function would be symmetric with respect to the origin. However, if you plug in minus x into the function f and you just get f of x back, that means f of x is an even function. And an even function is symmetric with respect to the y-axis. Of course, most functions are neither odd nor even. Those are special cases. So But we always want to check that because that helps us knowing something a lot about the function, its symmetry. So if I look at f of x equals 3x cubed minus 5x to the 7th, and I plug in minus x everywhere I see an x. So I have 3 times the quantity minus x cubed, minus 5 times the quantity minus x to the 7th. A negative number cubed is a negative number, so that brings out a minus 3x cubed. This becomes minus x to the 7th, so minus a minus is plus 5x to the 7th. Notice that's the opposite of what we started with originally. That's the opposite of this function. In other words, it's minus f of x. That tells us that f of x is odd. And the last example is we want to find any relative maximum or relative minima of the graph below. So a relative maxima just means like I'm at some point on the graph I would be standing at the top of a hill. It doesn't have to be the highest hill on the graph, but I'd be standing at the top of a hill. That would be a relative maximum. If I had a relative minimum, I'd be at the bottom of a valley, within my little local area of where I'm at. This graph doesn't have either one of those situations. This is an increasing function forever, right? It's just working from left to right. I'm going up a hill forever. There's no relative maximum or minimum. So this has no relative extrema. And I just talked about how it's always an increasing function for x. For x in minus infinity to infinity, x can be anything for this function.